Alright, I'm back, and now we're going to do part 2 of the lab, which is distance versus time graphs, velocity versus time graphs, and then acceleration versus time graphs. But before we do this, recall from our previous labs when we talked about graphs. So any time that you have a graph and it makes a straight line, now it could be a straight line like that, it could be a straight line like this, it could be a straight line like that. So anytime that a graph makes a straight line, that means that something is not changing, which means that something is constant. Now the question is, what is constant in the case of the ball that's falling? So you are going to look at distance versus time graphs, velocity versus time graphs, and then acceleration versus time graphs to see if something is a straight line. Now, on the other hand, if you've got a graph and then something is curving, then that means it's not a straight line, which means that something is changing. So something is changing whenever you have a curve, and then something is constant whenever you have a straight line. So we're going to be taking a look at that. So in order to figure out what is constant or what is changing, you're going to be looking at the slope m of your graph. And remember, here is the formula for slope. So slope is given by the letter m, so it's not mass, and then it's rise over run. And so, like for example, for this one right here, you pick out any 2 points on the straight line, and then this would be the rise part, and then this would be the run part. And so you need to have 2 points, point 1 and point 2, and then it's going to have y is going to go up and down, and then x is going to go sideways, and then it's going to be y2 minus y1 divided by x2 minus x1. And then we're going to use the units. So the unit of the up and down part, and then divide it by the unit going sideways, and then the units are going to tell you what the concept is that is creating that slope. So that's what we're going to be doing. Okay, now we need to click on the world button. So we're going to go back to the simulation. Remember to reset it. So the ball is back up here, and we're going to click on world. So world is over here. Okay, then the next thing that it says to do is that we need to select world and position, and then click play. Okay, so we're going to go back to the simulation here, world and position. So we click on here. Okay, now we're going to find world and position. So that's this one. And it makes a graph for us. So what do you think is the up and down part if we just clicked on world and position? Well, it's going to be the position. Okay, and so this part right here, that's where the ball is at. So that's at a 0 mark. And then what do you expect? Just take a guess. Time is going to be going this way, and then distance is going to be going this way. So what kind of graph do you think it's going to make? Do you think it's going to make a curved graph? Do you think it's going to make a straight graph? Do you think that nothing's going to happen? All right, so it's kind of important. Always make a prediction before you use the simulation. Okay, then we're going to hit the play button, and we get that. So notice that we're getting negative positions going down. Okay, and then the bottom one is like 103. So negative 103 is down here. And then we said that these blue dots, 1 second, 2 seconds, 3 seconds. So we've got 1 second, 2 seconds, 3 seconds. So there's the amount of time that is elapsed, and so that's going sideways. So now let's go back to the lab. Okay, so here's what we just did, and we're going to answer some questions here. Going up and down on the graph is the what the ball fell. Okay, number 9, going sideways on the graph is the what that has elapsed. Number 10, using the definition of slope and plugging in. Now, at this point, you are not actually calculating the slope. Okay, all we're doing is we're using the definition that the slope m is going to be equal to the change in the up and down part divided by the change in the sideways part. So that's all that we're doing here. So since the slope is changing, hold on, we're up right here. Using the definition of slope and plugging in the units of the slope, the graph represents the what of the ball at different times. So you put in the official metric units for the up and down part, and then you put in the official metric units for the sideways part, and then put it together, and then that is going to mean something. It's going to be the official metric units of something, and then you're going to put that in for right here. Now, since the slope is changing, so remember, so it's going to be doing this. It's going down like that. So it's not a straight line, so it is changing. This means that the what is changing, which means that the ball is doing what? Okay, so we know what the slope means from up here for number 10, and that slope is changing, so that means the what is changing, which means that the ball is doing what? Okay, now we're going to click on world and position and select world and velocity. So we're going to go back to here, and again we're going to click on this, but this time we want world and velocity, and so that's going to be this one right here. Oh, and before I do that, let's go ahead and reset it. Okay, now go back to here, and then world and velocity. Okay, and then hit the play button. Oh, now notice that this one is different. So this one has a different curve. Now we're going to do exactly the same thing that we did previously. So we're going to go back to here. Going up and down on this graph, what does it represent? So on the graph that you just made, what does the up and down part of the graph represent? And put that there. Going sideways on the graph is again the what that has elapsed. So fill in the blank there. Okay, now we're going to use the definition of slope, and we're going to plug in. Now the units for the up and down part are going to be different this time. So we're going to take those official metric units for the up and down part and then divide it by the official metric units for the sideways part. And the question then is, what does the slope represent? So the slope of that graph represents the what of the ball at different times. Okay, and then answer number 15, since the slope is is it a curved line or is it a straight line? This means that the what is constant. Okay, so go ahead and put that in there. All right, now we're going to do the third one is click on the world and velocity, and we're going to click on that, and now we're going to click on world and acceleration. So world and acceleration, what do you think it's going to be a graph of? So if the first one was a position versus time graph, and the second one was a velocity versus time graph. This one's going to be A, okay? And so now I'm not going to do it, so you get to do it. Going up and down on this graph is going to be the what of the bowl, and then going sideways on this graph is the what, and then what does the horizontal red line at the bottom of the simulation indicate? So it's way down there at the bottom. You'll see a red line that is horizontal, and then what is that trying to tell you? All right, so now we have introduced the concept of graphing to analyze the motion and to determine what kind of motion it is. So now we want to look at formulas. So we're going to take a break, and when we come back, we're going to be doing part 3, vertical motion equations.